Okay, so yesterday we did a little demo of a smart contract, and we've looked at Rust, we've looked at the Polkadot blockchain. Now we're going to talk about the Substrate. Substrate plus Rust are the two critical, plus Wasm are the critical pieces of the Polkadot blockchain. So today what we're going to do is we're going to look at, this is the Substrate developer hub. It's called substrate.dev, and I have it docs.en. I'm sure they have it in other languages as well. And this goes through the basics of what you need to know. An overview, the architecture, which we're going to have a look at. Now, if you gets a little confusing because I'm looking at it. First, I'm looking at OBS. So, they talk about the architecture. So this is a Substrate client, and inside you got remote procedure calls, your consensus, your telemetry, your native runtime, and they talk about some of the things that are necessary for the that are part of a substrate-based blockchain storage, which obviously you need in any blockchain. Someplace the block has to be stored someplace, and that's usually some kind of database, preferably some kind of distributed database. The runtime defines the logic of the database, maybe the contract, the smart contract like we saw the other day, or transactions. You obviously need a peer-to-peer network, because if you have distributed nodes, so they use the lib2p network stack consensus, and we've talked about that. That's the chain agreeing on, the agreement on what is the exact state. Remember, a blockchain is a kind of an infinite state machine. Infinite because the states are not limited. Remember, we spoke about how like a traffic light is a state machine, or a baseball, the players on the base paths are a state machine, and there are only a limited number of states. A traffic light can be red, yellow, or green, and it transitions in a certain way. It doesn't transition from green immediately to red. It transitions from green to yellow to red, and it doesn't go from red to yellow. It goes from red to green. On base paths, it doesn't go from third base to second base. They go from second base to third base. I mean, I guess they could in a rundown, but in general, the final state is either after a play, either a player is tagged out, or a player stays at the base they're at, or goes to the next base. Remote procedure call, and this is interesting. This is new, the telemetry metrics. So they have an embedded server for that. So they're trying to talk about technical freedom versus development ease. So Substrate node is the easiest. Substrate core gives you the most versatility. So you can pre-design and configure things with the node. With the frame, you can create your own runtime, which stands for Framework for Runtime Aggregation of Modularized Entities. So this is more of a templated way of changing your runtime. And core, you can just do something in anything that can target WebAssembly. So that would be Rust and other related, any language that can target WebAssembly. So C, C++, Rust. So they talk about the document documentation here. Installation, getting started on Windows. Well, we're going to do this on Linux. If I can keep my Linux box having enough hard drive space. And here's the learning section, goes through the technical items, block structure, transaction pool. That's the validated transaction. Okay. So they talk about, actually the transaction queue has two sorts of transactions. A ready queue that they can now be included in a pending block, and a future queue waiting validation. So validation, as they mention, is a transaction index, correct? Nonce, and we've heard that, we've seen that in regard to Bitcoin. Checking the, what it is there is the proof of work is, if I remember, finding the nonce that provides the most, that provides a value that is below the threshold when hashed. So remember, you have all these values in the block, it's hashed. If it falls below whatever the level is in terms of the hash value, they get to be the first one who does that, in essence, solves the problem and gets to create the block. Does the account have enough funds? Is the signature valid? So these are all the things. And there are various things they talk about here in the runtime. And I will include this in the notes. So the runtime is the logic that defines the behavior. Referred to state transition. Again, we talk about states. So the runtime for a baseball, base paths would be the rules of baseball. What happens? What's the function that gets a ball player from first base to third base? And this is kind of their pre-built stuff, and these are, so substrate with frame. So these are the frame palettes. The runtime are some of the algorithms that have been developed. Grandpa is the one, of course, that's used in Polkadot, and there are others. And it has primitives, hash, digest, header, all information. The block is a combination of series of the header and items put into the block. External. Extrinsic is a key concept. It's a piece of data external to the blockchain that is recognized by the blockchain. So it could be signatures or encoded instructions as defined here. And they go through here. This is all the basic information. Smart contracts. We looked at in smart contracts the other day. If you're interested, this is a great place to start. We are going to be going through some of the tutorials. In particular, this one I think is interesting. This is the basic creating your first substrate chain. And we're also going to have to install it, and that's in here, installation. So what we're going to do, and I think tomorrow, is we're going to run this, we're going to install, and then we're going to play around with this this tutorial here and see what we get. And we will remember that, unlike yesterday, that we have to set everything, let's see, set our little, where did it go? Yeah, set our little actually it's here, set this to the local node so we don't end up trying to interact with an actual test chain. Let's see, didn't flip it. Thought it would. Oh well. So at any rate, that is all for today. I think we've got a cool demonstration lined up for tomorrow, and I hope you can be there to see it. This looks like it's going to be fun. And once we get our hands on, between Substrate and Rust and Wasm, we're going to be able to do some cool stuff. And I do want to talk a bit more about Rust, because it is, from the stuff I've been reading, even a more interesting language than I initially had in my head. And basically say the key thing to me is I'm comparing to Python. Now, Python is a cool language because you can write stuff in Python to control something like this, which is a little micro processing thing, or you can write something to control, do data science. And now I don't think Rust gets quite to the data science level in terms of what you're able to do, what people are doing, but you can control microcontrollers, and that might be an interesting experiment. So at any rate, hope you've enjoyed this, and again, we're going to have a cool demo lined up, and I will, if you've enjoyed this, please give it a like. Of course, any questions, feel free to put them in the comments, and I will endeavor to find an answer. No guarantees, but I will definitely look at it and see if I can find you an answer. And then if you want to see more, click the bell and subscribe. So thank you, and I will speak to you tomorrow.